Hello, my name is Warren Young, aka Tangent of TangentSoft.net. This is Tangent Tutorial 3, Surface Mount Soldering Techniques. In the previous tutorial we covered basic through-hole soldering techniques. In this tutorial we're going to get a little bit more advanced and get into surface mount. Alright, the two basic rules for populating a circuit board are smallest to largest and inside to outside. You want to populate the smallest components first, because if you do the big ones first, then they're going to be in your way while you're trying to get in there and try to do the small ones. And then you want to do the ones more towards the center of the board rather than the ones toward the edge, because the ones at the edge will kind of block you while you're trying to work on the center of the board. Now what I've got here is one of my pint prototype boards, and on the pint it's kind of a toss-up between whether the smallest components are these little resistors and capacitors or the surface mount op-amps. There's not really a big difference in size between them, and so because the surface mount op-amps are towards the center of the board, we're going to do them first. Now one thing about an SO8 op-amp is that there's two ways you can put it on the pads, 180 degrees opposite from each other. With a dual channel op-amp, the V- and V+ pads are oriented opposite each other, so if you put it on backwards, you're going to apply voltage backwards to the chip. This will blow it up very quickly. So it's important that you get it on the pads correctly. Now on the circuit board you can see there's a little round dot on the silk screen. Sometimes there'll be a little notch or some such thing. It's going to be indicated somehow on the circuit board. There's no real standard. On the chip, again, there's no standard. The only common thing that I've ever found on SO8 op-amp chips is that one edge will be beveled a little bit. So I'm going to show you this little animation. You can see that bevel along one edge. Some chips will also have a little divot near one corner, or they'll have some kind of notch. Between those three markings, you ought to be able to figure out which one is pin 1 on the chip. Alright, there are several different techniques for soldering these sorts of chips. The one I like to use is I like to tin one pad. I'm tinning the pad that's easiest for my right hand, because I'm right-handed, to get to. Okay, this one in the upper right-hand corner. And then off camera here, I'm grabbing the SO8 chip off the desk. Now I'm going to hold it at kind of a shallow angle here, you see, so that it's parallel to the board. And I'm going to just reheat this pad, this first pad, and slide the chip into place. Okay. Now I'm not worrying about getting the exact position right, because while I've just got one pin soldered, I can use my tweezers here, which I showed you in the first tutorial, to tweak that part around until I got it right. As long as it's reasonably close, it's not a problem. You don't have to get it precisely correctly on the pads. If it's really badly off, don't try and twist it on the twist that first pin. You can put a fair bit of stress on that first pin. It's not a big problem, but if you get it completely wrong, just let it cool off for a sec, desolder that first pin, and try again. Okay, now having got that first pin, I'm going to do these other 8 real quick. And I'm just heating the pad and the pin at the same time and flowing a little bit of solder onto both. And as you can see, I'm using this same $9 iron I used in the previous tutorial. This is not a high-end iron. The tip is not all that small. I'd actually rather it be a little smaller. The point is that you don't need fancy equipment to do these chips like SO8 chips. Now what I'm going to do is I've got a little bit of solder on some of these other pads I shouldn't have, so I'm taking my solder braid, desoldering braid that is. I'm just heating the joint through the braid. Okay, and that just cleans up the extra solder. I haven't made any bridges. However, there's a little technique you can use here, and that's just take your iron and run it along the edges, and that will pick up a little bit of solder. You can see it on the tip there, and that will help to, it's actually better to do it from this angle, but I can't do it the way the helping hands is, and I don't want to unmount it for the video purposes. Okay, so I'm going to do one more of these pads here. I'm just going to Put a little bit of solder on that. Now you can see that the solder has flown across this via and onto this cap pad. That's not a problem. We're just going to ignore that. Now over here you can see this chip, and I've oriented it so that the bevel is, you know, towards me, since that's the direction of the pin 1. And I'm going to reheat this pad and slide the op amp into place. Give it a few seconds to cool, twisting that op amp around a little bit to align those pads again. And now I'm going to do this opposite pin and the other 3 on this side. As I showed you in the previous tutorial, I'm not worrying too much about cleaning the iron. You know, I just did just now, but as long as you're doing these pins, you know, really fairly quickly, you know, you don't have to clean the iron every joint like some people will tell you. And I am redoing this first joint I did, because while I was using it, you know, I'm just using it that first time just kind of to tack the chip down, not so much to, you know, to solder it formally. So I do redo that joint. Just blow a little bit more solder onto it. All right, now I'm going to show you this technique again. I'm just taking the flat of my iron and laying it on the edge of those chips, on the edge, across these pins, and that's picking up excess solder. That makes the joint look a lot better. It picks up any excess solder, and if you have any mild solder bridges, that'll also usually clear it up. If running your iron tip along the edge of those pins doesn't clear up a solder bridge, use your desoldering braid. So, and again, while I was doing that, I got a little bit more sloppy, so I'm going to clean up these pads. And that's it. The next thing I'm going to add to the board is a resistor, and I've got it in this cut tape packaging. What this packaging is made for is machine assembly. It feeds, you know, using these sprocket holes through the machine, but that's you know, it's not really for us, but as hobbyists. But you know, that's how you're going to find most surface mount resistors. So what I'm doing is I'm taking my sharp tweezers, which is another reason I like them, and I'm just going to use that to peel back this film that's on top, and I'm going to expose 2 resistors because that's how many I need at the moment. I'm going to dump them out on the desk, and then I'm going to use my nippers to cut off the excess. That way the end is sealed again, so it's not going. I'm not going to be able to, you know, peel that off and then dump the rest of the resistors out. So I like to keep the resistors in this cut tape package because you know, that way it you know, the resistors all stay together. So once again, the technique is to put some solder on one pad, and I'm doing the pad that's closest to my right hand. Here's the other pad here, so I'm gonna, you know, I'm doing this one over here instead of this one. It's not important which direction you put a resistor, so I like to put the label so that it's facing towards me as I do the soldering work, so that way it's easy to read, you know, a bunch of resistors on the board once you've got them down. So once again, I'm reheating this pad, and I'm just going to slide that resistor into place. Give it a few seconds to cool. Et voila. And I'm going to do this other pad, heating both the pad and the resistor lead end. And there it is. Once again, I'm going to do another one. So this one over here, and grab the resistor up off the desk. Once again, I've got it at a nice shallow angle so that I can, you know, get in here and just slide that resistor into the solder puddle. Give it a few seconds to cool, and that's it. Heat the pad and the resistor lead, flow a little solder in there, and that's it. Surface mount resistors. They look kind of tiny at first, but they're really not that hard to handle. Okay, so I've turned over the board, and on the back side here, we've got some capacitors, and I'm going to show you this one here. This is a tantalum capacitor. Now, tantalum capacitors are polar, which means that there's a right way and a wrong way to put them on the board. On the board, you probably can't see it on the camera, but there's a little plus sign on the board here. That means that the plus leg goes this direction. And on a tantalum capacitor, it's the positive leg of the cap that's marked as plus. So if you can see on the camera, there's one leg that's side that's a little darker. It's got kind of a brownish band instead of the light yellow of the cap. That marks the positive leg. So I'm going to orient it this direction, and I'm just going to heat this pad up and slide the cap into place. Other than that, it's just like a resistor. It just matters which direction you put it on the board. Okay. And I'm going to solder up this positive leg. Now on the pint, it happens that this capacitor over here, which is the same kind, is oriented the other direction. So make sure you get that direction correct. Now the other thing is there's a couple of resistors in here. If I was doing this for real, I would do those first for two reasons. First of all, they're shorter than the caps, so that's the smallest to largest rule. Also, they're between the caps, so inside to outside. But for educational purposes, I'm going to just, I'm going to ignore the resistors. Later on, I'm probably going to populate this board for real, and that means I'm going to have to do those resistors in between the caps, and that's going to be a little more challenging, but it can be done. So again, I've got the positive leg, oriented the opposite direction in this case. I'm just going to heat up that other leg, and that's it. So these are even easier than the surface mount resistors because they're bigger. And so getting still bigger, we've got a couple diodes on the back side here. Now you may be able to see it, but there's a little arrow on the board here that's pointing the direction towards the negative lead. This comes from the way the diode symbol is, and that's an arrow pointing towards the negative lead and then the bar on the negative lead. On one leg here, there's a stripe, and you can think of that as the bar on the diode symbol. So again, that marks the negative lead. Now these tantalum capacitors, the stripe is on the positive lead. On the diode, it's on the negative lead. You got to keep that straight. So once again, I'm going to heat the pad that's closest to my right hand and grab the part off the desk with the negative lead toward, point this direction, since that's the direction it goes on this board. Slide the part into the puddle and solder the other leg. Now these big old diodes, these are positively trivial. Not a thing to worry about on those. So that's it, surface mount soldering. It's really not that hard, at least at these sizes. The resistors you've seen are 1206 size. That's almost the largest resistor type they make. Sometimes you'll find 1210 size, which is just slightly larger. These capacitors are even larger, and the diodes still larger. The SO8 op amp is probably the most difficult one to do, and it's really not that hard either. The really small surface mount stuff, yeah, that can be difficult, but even with a cheap iron, you can do this surface mount stuff at this level. Okay, in the next tutorial, I'm going to show you how to desolder parts, which you occasionally need to do. Thanks for your attention, and goodbye.